Welcome to the AED podcast series. I am Sathya Gopalakrishnan, Associate Professor in the Department of Agricultural, Environmental and Development Economics. And I'm here today with my colleague, Professor Yongyang, Associate Professor in Environmental and Computational Economics in our department. Dr. Kai's work focuses on large-scale dynamic models of the integrated climate economy with specific attention to fundamental uncertainties in the climate trajectory and economic productivity at a global scale. So his work is at the frontier in understanding interdependencies at a global scale and pushes boundaries both in economics and the science of climate change. Welcome, Yongyang. Welcome to this podcast.
Thank you, Sathya, for the nice introduction.
Great. So let's just start with, how do we pay for carbon emissions, and how do we think about the impact that economic activity has on in the environment? And so if you can speak to the idea of the social cost of carbon and how we might be able to measure this concept, that's a great place to start.
Okay, so first, there are many reasons that mitigation is very challenging. Climate change is a global scale problem. So carbon emissions from any place will increase the carbon concentration in the atmosphere, then increases the global temperature. So this requires globally cooperative actions. Future damages from carbon emissions can be very different across the countries. For example, a higher temperature may be beneficial to Russia and Canada, as their land previously was covered by ice. Now it becomes more and more suitable for economic activities. In contrast, Africa countries and India, they may have a much larger damage from global warming. Their temperature has already been high for living there, but now even if just a small change, 1 degree Celsius increase of temperature may lead to a significant damage. So, for example, water may become more scarce there, and more land may become be transformed into desert. Different damage levels across these countries make it very hard to cooperate across these countries globally. Some countries, they are poor, and so they cannot afford this extra cost of mitigation. And also, people may think that climate change problem can be solved easily and less costly in future. Private investment, they may not be able to get any profits if there is no support from government or public funds. Future temperature damages, they are very hard to predict. They are so uncertain, and so that's why it's very hard to reach a consensus on how much we should mitigate. We have a concept called social cost of carbon, you just mentioned. So that measures the present value of future damages from the one extra carbon emissions today. Present value basically just like, so you have some discount, future damages, you need to discount it back with some interest rate, something like that. This measure tells us with this social cost of carbon, then how we should choose our optimal mitigation policy. Because the future is so uncertain, so you say future damages, you don't know what are their exact values. You just based on your prediction. The future is so uncertain, you have no idea how large, how small, in fact. Mm-hmm. So and also when you say present value, so we say discount rate, so using something like interest rate. So that what's your interest rate in future? We don't know. What's the good number? And also, climate change is not just investment like your monetary thing. It's also people's life. So you cannot use a simple, just one number, say, I use interest rate to present it. This is a more ethical thing. How we do these things in our literature, so basically we build a model. So we build a model, then we create this we call it an integrated assessment model. So it's integrating this economy and the climate system. Climate system is a very complicated system, and the economy itself also is not a simple system. So I integrated them together, and also you need to know that all the future parties. So that's a very complicated model. It's a bigger model. That's why it's computationally it's intensive.
If I got this right, you said that the social cost of carbon is the expected damages over the long run from an additional ton of carbon emitted today. And so in the literature, we talk about this being one number. It's, $25, ranging from $25 to maybe over $100, right? But this is one number. Why is it one number across the world? And you initially started with different damages. So why is it one number and not different numbers across regions?
Because this social cost, this is a social problem. It's a global problem. Your carbon emission, it from one place will affect everywhere, basically. Cost we are measuring is in fact is global. So that's why we usually say social cost of carbon should be a global concept. But it doesn't mean you need to impose exactly the same climate policy like carbon emission targets on every country, because different countries, they have different situation, different economy. So then it's harder to impose the same tax or same other targets. But if you don't impose these same targets, then it has something like a carbon leakage problem. So, carbon intensive places, they may export things to carbon less intensive places.
So your work really focuses on this uncertainty and how we can account for these uncertainties in the modeling, which is really innovative and pushing where our current knowledge is. And what is the argument for why you find that the social cost of carbon, the potential damages that we are imposing, are actually larger when we think about the uncertainties, rather than and the implied policy being we should act sooner rather than wait a little bit longer? So why not, if we were to wait, we expect technology to get better, we expect GDPs and global income to go up. Why is it that we should act now rather than wait longer? And how does your model help us understand this concept?
So our future is uncertain. So if you just think using expectation, it misses one thing: risk aversion. There's a house, that house might or might not be destroyed by fire in future. Risk averse people, they may want to buy insurance to cover potential damages of their house in future. We know, in fact, the future, the fire probability is very, very small. So if you just think it's expectation, that meaning that number is very small. We can also see the insurance as an investment here. So if for this kind of fire insurance, we are very happy if the investment has a negative return. Similarly, for the climate change, it's also very uncertain in future. And so then some mitigation can be viewed as an investment instead of a cost. Climate change mitigation, their return could be positive. So it's much better than insurance, because insurance, usually they cannot reduce the probability of fire or its damage, right? But mitigation may be able to reduce the future temperature and the future probability of catastrophic events and the future damages. So if there's no mitigation, then future damage may be very huge. So then future GDP could be smaller than a case with mitigation today. So you think, yeah, the future is more wealthy than today? Basically, it's right. But if you do mitigation now, future even more wealthy than today. So then why don't do investment do this mitigation now?
So the takeaway is that we think about mitigation as an investment rather than a remediation or a recovery. So it's not
That's
to
right.
fix the problem, it is actually to invest in reducing future damages for increasing overall well-being in the future.
Yes.
Is that right? Shifting a little bit to what our current world that we live in, a large contributor to carbon emissions is economic activity. And we are living through a time where a lot of economic activity has come to a halt and is only slowly recovering. So in this, COVID-19 era, can we say that this pandemic has been a significant non-marginal, not a significant shock to the system that could potentially be large enough to reverse the effect of carbon emissions, or to really act as a tipping point? And you might have to tell us a little bit more about what a tipping point is, but could it be that we can get past a point where reversing the effects of climate change could be easier after this long pause in economic activity?
The pandemic may lead to significant reduction in carbon emissions, but so far, this is only 1 year reduction. So I don't know if it will be 2 more years or something like that. So if in the next year, the pandemic is gone, then we can expect a rebounding effect. So then carbon emission in future will be still large if there's no more mitigation. So currently, the carbon concentration in the atmosphere is nearly 900 gigaton of carbon. And the 1 year global emission is about 34 gigaton of carbon. So 34 versus 900, so it's not a very big deal. So only 1 year reduction of carbon emissions is far away from controlling temperature. You may just think you may delay 1 year, just think that way. So it will require many years effort to control carbon emissions, reduce the carbon emissions, and then control climate change. But I hope it will not be caused by these global pandemics again. So, so that's from my own view. This pandemic will not cause a tipping point event to revert the climate change. Talking about a tipping point, so typically we mean a tipping point means if you pass a system, a climate system or some system, if a system passes a threshold, then the system will convert to a completely different system. And usually it's irreversible. So this kind of we call a tipping point. So for example, like ice sheet melt, Greenland ice sheet melt, Antarctica ice sheet melt. So once it melts, from the science tells us it will require 1 million years to recover it. So basically it's irreversible. So, but if it melts, we know it will have a higher sea level, then several meters higher typically. Then some cities like New York could be underwater. This is a kind of irreversible things usually we are worried about in the climate change. So now is not talking pandemic, I'm talking these climate tipping points. This picture represents 5 major tipping points in my paper published in 2016. So here we see that Greenland ice sheet is one tipping point element. So, and this is Antarctic thermohaline circulation is another, second one. And Amazon rainforest is the third one, and El Nino is the fourth one, and then West Antarctic ice sheet is the 5th one. So these are 5 major global tipping elements and tipping points. They will affect each other. So that's very uncertain. So like if ice sheet melt, then it may increase the probability of collapse of an Atlantic thermohaline circulation. If Atlantic thermohaline circulation collapses first, then it may reduce warming of Greenland, so then it may reduce the probability of the melting of Greenland ice sheet. All these things the climate system is very complicated, so that's why it's also harder to compute the optimal social cost of carbon here.
Thinking more maybe at a slightly smaller scale rather than a global scale. If we were to think more locally or regionally, there's a lot we have to do to recover from this pandemic, right? The economic impact is huge. And in one of the other podcasts, we talked with Mark Partridge, who gave us a little bit an insight into how unemployment is going up and the impact that this pandemic has had on the labor sector in Ohio's economy. So one question, just thinking, is are there ways to simultaneously address the economic problem and the environmental problem? So are there ways in which corporations, for example, could think of more flexible work policy? So if we all, when we are done with the pandemic, if we all did not return to 5 days a week in our offices, but instead went back only 3 days a week as a permanent change, is that, and I'm just suggesting this as an example, but are there ways to recover economically from the pandemic that could simultaneously address the environmental challenge, or are they two different things that we really do need to think about as different problems?
I think these things are all connected. So how much correlation there maybe depends, but they are all connected. Like pandemics, there are some research work showing the increased temperature increase probability of pandemics. This is environmental thing. So you see, if we can control the climate change, well, maybe then we also can reduce the probability of pandemics. So then I think as a researcher, if we could, then it's always good to integrate all these elements together, because the system, they are all correlated. Our pandemic events affect economic activity, and economic activity affect climate change. Climate change may affect the pandemics, and also climate change affect economics. And also, you just mentioned economic activities, will affect the pandemic thing too, because nowadays we have more and more high-speed transportation. So then the spread of pandemics is faster and faster. And if you have more and more, you go to office working, more social communication, so then you have more interaction, then you will have a higher chance to get infected. So all these are connected. So I think, it will be great if we can integrate all of them together as a system, as a model, then we find the optimal solution. But of course, model is just an abstraction of the world. You cannot really replicate the world perfectly. So, but it can tell us some useful information. Just like the social cost of carbon, we have many models. So different models give us different estimate of social cost of carbon. And even the same model may give you different numbers of social cost of carbon. But all these models, they may still can tell you, so okay, the minimum of the social cost of carbon is something like 20. Then we know at least 20 is a good number, is better than 0. So that's, I think, is still useful to this. It will be great if we can, yeah.
Great. Thank you, Dr. Kai. This is a really interesting conversation, and And I'm sure we will be able to continue and catch up again later. Thanks a lot.
Thank you, Sathya.